What it do? It's your boy Codehova from Combinator. We're pimping swift. We're going to be talking now about enumerations, aka enums. Alright, so what enums are they're a group of related values. And it's, let's just say, transportation. So you start off by declaring an enum by saying enum. Okay, E-N-U-M. And then say transportation. So what enums have when it talks about the related values are cases. So we got cases of driving, we got cases of flying, we got cases of training, and we got cases of biking, we got cases of walking. So let's just get rid of the INGs, right? Train. So we could drive, we could fly, we could train, we could bike, we could walk. And if we're gonna say mode of transport, and then we're gonna explicitly declare this of type transportation, if we press, then we could say transportation dot, and we got all the cases. See? So we could drive, we could train, and when you have an explicit declaration, like mode of transport, right? You could omit this type. So the compiler is going to know if you write semicolon transportation, it knows that it's going to be one of these 5 cases. All right. So we have all these cases with no related values. So we could make this even simpler. So all you need to do is boom. So you have this enum transportation. You have a enum type called transportation, and it has these 5 cases. All right. So that's just an example of what's up. And the reason why transportations are good is because you have a locked set of related values. So and not only is it locked, when you're writing your code, if you make a mistake, a misspelling, the compiler is going to tell you that there's a problem. So if we just write tran, we're going to see that there is an error. And the error is type of transportation has no member called tran. Boom. So we look at it and we're like, all right, I made a misspelling. Good. And there you go. You're good. So that's the power of the enum. So another thing is that these enums, they could also have related values. But, I have this enum type. It's not that fun. So let's make it fun. All right. Let's call it drug. So we're going to have cases. And the cases are going to be trees, case, heron. All right. Well, let's keep it real scientific. Marijuana. All right. Then we got heroin. Then we got ecstasy. Then we got cocaine. America's cup of coffee. And what other drugs are there? There's so we got pro-meth. All right. And what else is there out there? Mushrooms. Psychedelic mushrooms. Okay. So, there's so many drugs out there. Let's just keep it simple. A convention that you should follow is definitely, you're going to want to alphabetize your cases. It's going to be a lot easier for you to be able to locate and use the enums. So H is definitely up there. Mushrooms. Boom. Okay. So what can enums also have other than cases? They are able to have computed properties and also functions themselves. So let's just create a computed property for now. And let's say I'll think of it. We'll get with a stated computed property in a later video. But again, so we have all these cases. In my opinion, this is a lot easier to read. But if you're a type of person who just wants to keep everything super duper simple and concise, you could just create it all in one line. So if we had a favorite drug or least expensive drug, and it's going to be of a type drug, if we press the period, we're going to get access to all these different cases. So in my opinion, I would say marijuana is probably the cheapest. And so if we run that, we have the marijuana class. Now this is just going to be the enumerations, enums, introduction video. We're going to keep digging in, so I'm going to end it right here. It's your boy Codehova, Fly Combinator. We're pimping Swift. Let's get it.